Welcome back, sixth grade, to Unit 8, Lesson 8, where we'll be talking today about finding the area of compound rectangles, which we did yesterday, but this time we're going to need to use rectangle properties in order to help us. Take about 20 seconds to make sure you are set up for class. These should look very familiar. Like I said at the start, today's problems are going to look very similar to yesterday's, but there's going to be a little bit of a tricky component where we might need to solve for a missing dimension. We're going to walk through two of those problems together before you get time to have a lot of practice with solving these complex area problems. Now we're going to start with a question that should look very familiar. It just says, what is the area of the figure below? There's one difference based on yesterday's lesson, and that's that not all of our problems today are going to be in the coordinate grid, but that's okay because we see a lot of dimensions that are given to us. The first thing I realize when I look at this figure is this is not a regular figure, meaning I do not have a formula to find the area of this figure. But I do have a tool from yesterday that I learned in order to find the area of this figure. And that tool is I can decompose this figure into two figures that I do know how to find the area of. And as I look at this, I quickly see that I could make two rectangles. As we learned yesterday, there are two ways in which I could decompose this figure. So that we're all finding the same areas of the same rectangles, I'm going to choose to decompose this vertically into rectangle A and rectangle B. I know the next thing that I need to do is to find the length and width of each of these rectangles, because once I have that, I can simply multiply the length and the width to find the area of each rectangle. Rectangle A is very straightforward. It's given to me. The length is 8 and the width is 13. Now, when I look at rectangle B, if I look very quickly, I notice that 6 could be the width and 18 could be the length. Now, that would be what I would think if I wasn't being super careful. But when I look a little bit closer, I realize that 18 inches represents the length of the entire bottom of my figure. But I decomposed my figure. So the length of rectangle B is only a portion of 18. So how can I find the length of rectangle B? Take 30 seconds on your own to see if you can find the length of rectangle B. We're going to walk through this together because this can be a little challenging to see. I already said that I know the length of rectangle B is not 18 because 18 is the entire length of both rectangles A and B. So I need to look at what information is given to me in my rectangle so that I can find the length of rectangle B. I see at the top here where I just put that red line is 8 inches long. And I know that opposite sides in rectangles are congruent or equal, which tells me that I can bring that red line that represents 8 inches down to the bottom of rectangle A, because I know that those sides are equal. But that still doesn't give me the length of rectangle B. So I need to figure out what is the length of rectangle B. As I'm looking here, I see that the entire length of this whole line is 18. A piece of it is 8, and another piece is missing. So I know from 5th grade that I could say that 8 plus that unknown part will give me 18. In other words, 18 minus 8 will give me my unknown piece. I know that 18 minus 8 is 10. So the length of rectangle B is 10 inches. Again, I found that by using the property of opposite sides of rectangles are congruent to realize that I could use a subtraction expression to find the missing length. I can now go back and label that 10 inches as my length of rectangle B like I did here. Now you guys are pros at this. You know how to find the area of this entire figure. So pause the video and take 1 minute. What is the area of this entire figure? Compare your work with mine. You should have gotten 104 square inches for rectangle A and 60 square inches for rectangle B. Lastly, we need to add those two values together to get a total area of 164 square inches. If you got 164, make sure you have the units there. Your answer technically is not correct unless you write the units of square inches. Pause the video and make sure you have this work on your paper. What we just did was use the property of rectangles in order to find missing dimensions when decomposing our figure. That brings us to our key point for today. We can use properties of rectangles to find missing dimensions. Specifically, opposite parallel lines of rectangles are congruent. Pause the video and copy this down. Let's apply this key point to another problem. We see this problem here, which is slightly more complex than our previous problem. It says, Edwin is retiling his bathroom using 2-foot by 1-foot tiles. He drew a picture of the floor in his bathroom below to help him plan. How many tiles does he need to buy to cover the entire floor? This is slightly more complex because it's a word problem. And we know anytime we're solving a word problem, the first thing we need to do is reread and understand, what is this question asking me to do? Then we need to write a plan. Pause the video and do those two things. Identify what is this question asking you to do, and second, what plan can you write to solve? Take a look at the plan that I wrote and compare it with yours. First, we need to decompose this figure into two rectangles. Then we need to find the area of each rectangle. Then we need to add the areas together to find the total area. Next, the question's not asking me to find total area. It's asking me to find a number of tiles. So I need to find the area of a single tile. Then I can divide the total area by the area of a single tile in order to find the number of tiles. That's because I have a total and a group size, and then I need to find the number of groups. Now, looking at step 1 of my plan, as we know, there's two ways in which I could decompose this rectangle. So that we're all on the same page, let's decompose it like this into rectangles A and B. Rectangle A is straightforward. We see that the length is 20 feet and the width is 4 feet. Pause the video and take 30 seconds. What are the length and width of rectangle B? I'm going to show you an example, two different examples of a length and a width for rectangle B. Your thinking job is, which scholar do you agree with, scholar 1 or scholar 2? Scholar 1 thought the length of rectangle B was 10 and the width was 8. Scholar 2 thought the length was 10 and the width was 4. Who's right, scholar 1 or scholar 2? Your teacher's going to pause the video and ask you to vote. If you said scholar 2, you were right. Scholar 1 made the mistake of thinking that 8 was the entire width. But we know from earlier today that we can use rectangle properties to find missing dimensions. So I'm going to show you how I went about doing that for rectangle B. The first thing I looked at the bottom of your screen was that the width of rectangle A was 4 feet. That's where you see that red line. Then, because I know that opposite sides of rectangles are congruent, I can actually take that 4 feet up to the top of rectangle A and label that 4 feet. That still doesn't help me yet with the width of rectangle B. But what I do know is that that entire line at the top is 8 feet. So if I know that the entire piece is 8 feet, and one part of it, rectangle A, is 4 feet, I know I can find the width of rectangle B by subtracting 8 minus 4 to find my missing dimension, which is 4. I can then label rectangle B having a width of 4 feet. You guys can take it from here. You have a few steps left to complete the plan. Take 90 seconds to pause the video to see if you can come up with a strong final answer to this question. Go. The first piece that you had to work on was finding the total area. As you can see here, I got a total area of 120 square feet once I added the two areas of rectangle A and rectangle B. The next step was to find the area of a single tile, which was easy because we just had to multiply 2 by 1, which gave us 2 square feet. Lastly, when we divided, we got 60 tiles. You can see my answer statement there says, he will need to buy 60 tiles to cover the entire bathroom floor. Pause the video to update your work if you need to. I want to bring us back to our key point, which said that we can use properties of rectangles to find missing dimensions. Opposite parallel lines of rectangles are congruent. We use that in both of the problems that we did today in order to find missing dimensions. In your work today, you are going to need to find missing dimensions when you decompose your rectangles. So be very careful and don't assume just because you see a number that it has to represent a dimension. You see your CFS for your work today. Annotate as always, decompose your figure, and label your dimensions. Only if you label your dimensions will you be able to realize any missing dimensions that you need to solve for. Next, write your formulas, show all of your calculations, and write that final answer statement. You guys are absolutely going to crush your work today, and I am excited to close out our unit with you tomorrow. Good luck on your work today and have a great afternoon.